Okay, this is a problem from your practice in lesson 1, unit 2. So this is practice 8.2.01, and this is problem number 3. So in Amplify, this is problem number 3. I think it's actually slide 4. It's problem number 3. It will be titled problem number 3. Okay, we're going to write down the problem and we're going to solve it together in this video. And so you'll have the answer to problem 3. And I chose this problem because it has a lot of information that you can use to solve several problems in this unit. Okay, it's a little bit to write, but it's going to be really useful. Okay, rectangle, talking about rectangle A, just a random rectangle that they come up with is 12 centimeters by 3 centimeters. This is just a rectangle. There's no example picture in the problem. It's just a rectangle that they're talking about. And then rectangle B is a scaled copy, which is what we talked about in the scaled copy notes video. I'm going to underline that. Is it drawing in this color? Let's see what color. Scaled copy of A. And then it gives you some options. It says select all pairs that could be, important word, could be dimensions of rectangle B. Okay, so we have information, so it's important to understand the information they're giving us. We have rectangle A, which is 12 centimeters by 3 centimeters. Rectangle B is a scaled copy of rectangle A, and then it says to select all the pairs that could be dimensions of rectangle B. So usually when they say select all the pairs, there's going to be more than one option. Not always, but usually. Okay, so the options that there are, let's see, the first one is 6 centimeters. This is just a checkbox right here. Centimeters by 1.5 centimeters. Okay, we're going to write down all of them. I want you guys to skip a couple lines so that you have space. We're going to do our work kind of off to the side here. We're going to draw little tables. So skip a little, leave a little space. You should have enough space. Maybe we'll skip 2 lines. The next one is 10 centimeters by 1 centimeter. See, I'm skipping 2 lines. Hopefully that'll be enough space. 18 centimeters by 4.5 centimeters. And then 2 more, 6 centimeters by 1 centimeter. And the last one, 80 centimeters by 20 centimeters. Okay, so we have to figure out if any of these dimensions are scaled copies of these dimensions up here. Okay, so I wanted to pull a calculator up here, but it's not letting me. So I'm gonna just hot purple. Okay. So for the first one, 6 centimeters by, let me use this space here. We know that we have our length and our width because it's a rectangle. And let's just say that the length is the longer side. Doesn't have to be, but just for the sake of this. So this is our original, right? This is rectangle A, 12 centimeters by 3 centimeters. I wrote it here in the table. And our possible rectangle B is 6 centimeters by 1.5 centimeters. So we're looking to see if there is a scale factor, right? We talked about a scale factor with scaled copies. That's a number that you multiply the side lengths by to get the new copy. So for this one, if I look at length, I can look at it this way. So I can look at length and length. I know that 6 times 1/2, I'm sorry, 12 times 1/2 equals 6, or 6 times 12 equals 6 times 2 equals 12. Sorry. So I know that I can multiply this by 1/2. You could also think of it as divided by 2. That's fine. But we are talking about a scale factor, which is always multiplication. So I do want you to start thinking about fractions and decimals as well. Okay, so the question is 1.5 half of 3. So if I did 3 times 1/2, or 3 times 0.5, which is the same as 1/2, do I get 1.5? So 3 times 1/2. And if you do that in a calculator, if you do 3 times 0.5 or 3 times 1/2, you do get 1.5. So this option right here is times 1/2. So that is a yes. Okay, I'm going to do a different color for the next table. Okay, so we're looking at the next one. I'm going to set it off to the side just a little to separate it from the last one. Okay, so same thing. I know we're doing a lot of work for one problem, but again, this is relevant to all the problems. There's a lot of information, basically a lot of notes that are going to help you as long as you study the notes and understand them. Okay, so we got our length times width again, and we have our 12 and our 3, which is our original rectangle A, and then we have 10 and 1. 10 length and 1 for the width. I'm always choosing the larger number for the length because the larger number is the length in the original. So I'm always choosing the larger length from the possibility rectangle. If I say triangle, I apologize. Sometimes I might mess up. Okay, so if we look at these numbers, I can look at 12 and 10, and I don't know off the top of my head what I would multiply 12 by to get 10. But if I look at the 3 and the 1, I do know 1 times 3 is 3, or 3 times 1/3 is 1. So if I think about it, I I know that 10 is not 1/3 of 12. I know that. I can test it out though. I could say, okay, 10 times 3 or 12 times 1/3, does that equal 10? But it does not. So times 1/3, no, it's a little question mark. No, that is a 3. Oh, that's a really bad 3. Okay. No. So this one is not an option for rectangle B. Okay. I know this is long. I'm gonna keep going. We can do this. All right, I don't want to use that color though. I'll use this color. Okay, so next one. Some of these you might look at and go, yeah, I know that is an option, but some of them you might have to actually, do the math and figure it out. Because like this one is, this is a decimal. Sometimes you might see, okay, yeah, 1.5 is half of 3, but not always. So it's okay to have to do a lot of work for one problem because then you understand it better. I know you guys don't like writing things down, but it's necessary. Okay, so again, original is 12 and 3, and the new one is 18 and 4.5. Okay, so this one you might not see a scale factor right away because this isn't like a multiple that you're used to, but it still could work. So I'm going to say, let's do a little bit of notes right here on this one where we have some space. So we need to know, okay, well, what would I multiply 12 by to get 18? So I'm going to write 12 times question mark equals 18. What would I multiply 12 by to get 18? And in order to figure that out, we can do the inverse operation, which is division. So we know that 12 times something equals 18. We don't know what it is. So we could do 18 divided by 12. And if you put that in the calculator, you would get 1.5. Okay. So we know that 12 times 1.5 equals 18. So that is our scale factor. As long as it works on the other side, that would be our scale factor for this scale copy times 1.5. Okay, now we have to check and see if it works for 3 and 4.5. So does 3 times 1.5 equal 4.5? Well, put it in the calculator. 3 times 1.5 does equal 4.5. Okay, so this one, and sorry, I don't have a lot of room, times 1.5. You can make your notes neater if you want. So this one is times 1.5 on both sides. 12 times 1.5 is 18, and 3 times 1.5 is 4.5. So we know this one is a yes. All right, just two more. All right, here, I'm gonna use this color. Oh, no, I don't want to use that color. It's the same as the other ones. Okay, so we're gonna do this one. All right. And remember to pause this video if you need to catch up. Although I'm going kind of slow. So, all right, 6 centimeters. Oh, sorry, original 12 and 3. And then our new one is 6 centimeters and 1 centimeter. Okay, so here's one, again, that we can probably figure out without using the calculator or doing any of these steps. So I know that 1 times 3, if I look at this, I know that 1 times 3 is 3. And if I look over here, 6 times 3 is not 12. So this, if I go this way, our scale factor is 1/3 times 1/3. But over here, it's times 1/2 because 6 is 1/2 of 12, not 1/3 of 12. So since they don't have the same scale factor, this one is not one of our options. Okay, last one. Okay, and you might look at it and go, no way, that's not possible, but we have to figure it out. We have to find out for sure. Okay, so I'm going to do it a little bit over here because we have a little more space over here. All right, again, same little procedure. This is basically, there's a problem like this on the test that you will eventually take, so you should definitely be doing these notes. Okay, length and width. Okay, so our original is 12 and 3, and this one is 80 and 20. Okay. I do not know what 12 times what equals 80. I don't know what that number would be. And I also don't know what 3 would be multiplied by to get 20. So I'm going to do the same thing I did with this part. And I'm going to do, okay, so I know 12 times something equals 80. I know we can multiply it by something. I know we can multiply it by something. It doesn't have to be a whole number, but something times 12 is going to equal 80 or a number very close to 80. So we're going to say 80 divided by 12. See how we're doing? We're moving the numbers around and we're using an inverse operation. So that equals, let's see, I'm going to use my calculator. I don't know if you guys are going to be able to see this calculator. I'm going to do 80 divided by 12 equals, and it's 6.66666666 forever. So I know that that's a fraction just because I know that, because I teach math and I know those things. But I am just going to write it as a decimal. But keeping in mind that if I put this as a decimal in the calculator, it might not give me a precise number. So we have to keep in mind that this is technically 6 2/3. But we're going to keep it as a decimal for now because I don't want to go too far into how decimals turn into fractions in this particular lesson. Okay, so I know that this over here is times 6.666666. Okay, and I'll just put the little multiplication sign right there because we're running out of space. Okay, so now I have to figure out, okay, does 3 times 6.6666, as many as I can, does that equal, question mark, 20? I don't know. We will find out. And I don't know if you guys can see my calculator, but we'll see. So we want to know 3 times, and I'm going to put as many sixes as will fit in my calculator because that will give me more of a likelihood of getting the answer that I want. And that equals 20. So I put in 3 times 6.66666666, and I got 20. So I know that 3 times 6.6, oops, I don't want to write it like that. I know that 3 times 6.66666666 forever. If I put a lot of sixes in the calculator, then I know I will get 20, and so this is also an option. So we did a lot of work for this one problem, but we got a lot of information and a lot of different ways to figure out if something is a scale copy. So this is figuring out what could be a scale copy, which is a little different than creating a scale copy. It's a little bit harder in my opinion. So we got this one, and this one. Now on Amplify, yours might be in a different order, so pay attention to the numbers. I think that is all for that video.